Good morning, everyone. In our previous lecture, we have seen the oxidizing character of potassium permanganate in acidic medium. There I have told you that KMnO4 works as a strong oxidizing agent. Because in KMnO4, Mn exhibit oxidation state of +7. All the 7 electrons have been moved away from manganese. So there is no electron left with the manganese atom. In that case, it will try to attract the electrons from the other species. And if it's attracting the electrons or if it is gaining the electrons, then it will show reduction. Because it is showing reduction, so it will act like an oxidizing agent. So we have completed oxidizing character of KMnO4 in acidic medium. Now today we will talk about oxidizing character of potassium permanganate in weakly basic medium. Now, all the points, all the steps that we use for balancing the redox reaction or the redox equation by ion electron method remains same. But here we will have one more step, because the reaction is taking place in weakly basic medium, so we will need presence of OH minus ion. So that is the only step which will be required here. It is not required for acidic medium. Now when weakly basic medium is there, then permanganate ion, which is obtained from potassium permanganate, gets converted to MnO2, which is called manganese dioxide or pyrolusite. In MnO4 minus, its oxidation state is +7, and in MnO2, its oxidation state is +4. +7 oxidation state gets converted to +4 state. So here it is decrease in oxidation state for manganese. And if we apply the oxidation number concept, decrease in oxidation number is called reduction. So when MnO4 minus gets converted to MnO2, it is called reduction of manganese. Now, let us balance this half equation by the help of ion electron method. So first represent the oxidation state, +7 gets converted to +4. Now, see the step number 1. Balance the reaction with respect to central atom. Here central atom is Mn. On reactant side we are having one atom of manganese, and on the product side we are having one atom of manganese. So this reaction is balanced with respect to manganese atom, so there is no need to use step number 1. Now directly move to step number 2. That is, balance the reaction with respect to oxygen atom. What we will do in step number 2? We have to see that on which side the oxygen atoms are deficient. For making up the deficiency of oxygen atom, we will add sufficient number of water molecules to the side where oxygen atoms are deficient. So if we check here, MnO4 minus gives you MnO2 in a weakly basic medium. There are 4 atoms of oxygen towards reactant side and 2 atoms of oxygen on product side. It means towards product side we are having 2 atoms less for oxygen atom. So for making up the deficiency of oxygen atom, we will add 2 molecules of H2O towards product side. So here in step number 1, so step number 2, we have added 2 molecules of H2O. Step number 2 is balance with respect to oxygen atom. And for this step, we will add sufficient number of water molecules. Now, step number 3, balance with respect to hydrogen. It's natural that when we will be adding water molecules to product side, then the other side, that is the reactant side, will fall short of hydrogen atom. If we are adding 2 H2O, then here on this side we are having 4 atoms of hydrogen. So reactant side is deficient of 4 hydrogen atom. For managing this deficiency, we will add sufficient number of H plus ions. H plus ions to the side where hydrogen atoms are deficient. So 4 H plus ions will be added towards reactant side. Now H plus ions cannot be there in basic medium. We require OH minus ions. We have to create basic medium, and for creating basic medium we will add sufficient number of OH minus ions to both sides. First we have to cancel out this H plus ion. It should not be there because we are dealing with the balancing in basic medium. So what we will do? For cancelling out 4 H plus ion, we will add 4 OH minus ions to both sides. So when 4 OH minus added on reactant side, it will cancel out H plus. And when 4 OH minus added to product side, it will create basic medium. For cancellation of 1 H plus ion, we require 1 OH minus ion. 1 H plus will combine with 1 OH minus to gives you H2O, water molecule. So 4 H plus with 4 OH minus gives you 4 molecules of water, 4 H2O. And this side we will be having 4 OH minus. Now just compare. Here we will obtain 4 H2O and this side we are having 2 H2O. What we can do? We can cancel out the number of H2O molecules. If we bring 2 H2O molecules to left hand side, it becomes minus 2 H2O. So 4 H2O minus 2 H2O gives you 2 molecules of H2O. So equation will be reduced to MnO4 minus plus 2 H2O gives you MnO2 plus 4 OH minus. H plus ions are removed and OH minus ions are added. In this manner, we will create basic medium. Now, the equation is balanced with respect to atoms, or we have followed mass conservation principle. Now we have to follow charge conservation principle. So step number last will be balance the reaction with respect to charge. On both sides, charges should be same. And what we do when we talk about the last step, that is balance with respect to charge, we add sufficient number of electrons so that the charge present on reactant side becomes equal to the charge present on the product side. So how many electrons will be added? Because this is a reduction equation, this is reduction reaction, so electrons will be added towards reactant side. Reactant by taking electron shows reduction, and whenever there is oxidation, electrons will be added towards product side. reactant by losing electron shows oxidation. Now, the important question, how many electrons is required here? So just see the oxidation state. Plus 7 state gets converted to plus 4 state. It means plus 7 to plus 6, 1 electron. Plus 6 to plus 5, 1 more electron. And plus 5 to plus 4, 1 more electron. It means total 3 electrons will be required. So MnO4 minus by gaining 3 electrons, shows reduction process. So this is the complete reduction half equation. MnO4 minus plus 2H2O plus 3 electrons gives you MnO2 plus 4OH minus. Now compare. In acidic medium, MnO4 minus was gaining 5 electrons and here it is gaining 3 electrons only. If a species is gaining more electron, it will be a better oxidizing agent. So here we can say that potassium permanganate is a better oxidizing agent in acidic medium if compared with basic medium, because here it is gaining only 3 electrons and acidic medium it was gaining 5 electrons. Now what it can do? In the weakly basic medium, KMnO4 oxidizes iodide ions to iodate ion. IO3 minus ion are called iodate ion. In acidic medium, it was I minus ion to I2, free iodine. But here, I minus ion gets converted to IO3 minus iodate ion, where oxidation state for iodine changes from -1 to +5. -1 to +5, increase in oxidation number is there. Increase in oxidation state is there. -1 state gets converted to +5 state. So when I minus gets converted to IO3 minus, it is called oxidation of iodine and it takes place in presence of oxidizing agent KMnO4. Oxidizing agents, substances which are responsible for oxidation of other, are called oxidizing agents. And thiosulfate ion, that is S2O3 minus 2 ion, where oxidation state of sulfur is +2, gets converted to SO4 minus 2 ion, which is called sulfate ion. The change in oxidation state, +2 state gets converted to +6 state. Again, there is an increase in oxidation state of sulfur. So this is oxidation of sulfur. Takes place in presence of potassium permanganate. Now, let us see one reaction. Balance the following in weakly basic medium. MnO4 minus plus I minus gives you MnO2 plus IO3 minus. Whenever an unknown equation is provided to you and it is to be balanced by using ion electron method, then your first step will be to find out which species is undergoing oxidation and which species is undergoing reduction. Here it is very clear that MnO4 minus gets converted to MnO2. So here it is reduction. +7 state gets converted to +4 state. And -1 state gets converted to +5 state. So conversion of MnO4 minus to MnO2 is reduction and conversion of I minus to IO3 minus is oxidation. Now you will divide after getting reduction and oxidation reaction. You will divide the equation into two half equations. First will be reduction half equation. Second will be oxidation half equation. Follow all the steps required for ion electron method for reduction half equation as well as oxidation half equation. And at last equate the electrons for both the reactions, both the half equations. Reduction half equation. It is fixed. Every time in weakly basic medium, MnO4 minus plus 2H2O plus 3 electrons gives you MnO2 plus 4OH minus. So here it is written MnO4 minus plus 2H2O plus 3 electrons gives MnO2 plus 4OH minus. Make it equation number 1. It is reduction of equation. Now move to oxidation of equation, where I minus gets converted to IO3 minus. What are the steps required? Step number 1, balance with respect to central atom. Iodine is the central atom, and it is already balanced because here we have one atom of iodine and here also we are having one atom of iodine. Now step number 2 is balance with respect to oxygen atom. What we do? We add sufficient number of water molecules to the side where oxygen atoms are deficient. So here we are having 3 atoms of oxygen and reactant side falls out of 3 atoms of oxygen. So we will add 3 molecules of water towards reactant side. So here we have added 3H2. Now step number next, balance the equation with respect to hydrogen. Because when we are adding H2O, the number of H atoms will be increased on reactant side. 3 into 2, 6 atoms of hydrogen is there on reactant side. So we require 6 atoms of hydrogen on product side also. So for balancing the equation with respect to hydrogen, we will add sufficient number of H plus ions to the side which is deficient of hydrogen. So here we will add 6H plus. Now extra step, creation of basic medium and removal of H plus ion. What we will do? We will add sufficient number of OH minus ions to both sides. Why it is required? Because one side it will cancel out H plus ion and other side it will create the basic medium. Because here we are having 6 H plus ions, so we will require 6 OH minus ions on both sides. So here we have added 6 OH minus on both sides. Now H plus with OH minus gives you H2O. So 6H plus with 6 OH minus gives you 6 molecules of H2O. And here we are already having 3 H2O molecule. So cancel out the number of H2O molecules or bring 3 H2O on product side. It becomes minus 3 H2O. 6 H2O is already there. Minus 3 H2O gives you 3 H2O molecules on product side. So here we are having 3 molecules of H2O on this side. And here we are having 6 OH minus. Now the last step. Balance with respect to charge. We have to add electrons. But on which side we will add the electrons? Because half equation is oxidation half equation. So electrons will be added on product side. And how many electrons will be added will be decided by change in oxidation state. -1 state gets converted to +5. It means total loss of 6 electrons will be there. -1 to 0, 0 to +1, +1 to +2, +2 to +3, +3 to +4, +4 to +5. Total 6 electrons will be removed. So here I have added 6 electrons on product side. Mark it equation number 2. Now the last step. We have to equate loss of electron with gain of electron. How to equate? Here we are having only 3 electrons and it is losing 6 electrons. So multiply equation number 1 by 2 and add the equation to equation number 2. We will be having 2MnO4 minus plus 4H2O plus 6 electrons gives you 2MnO2 plus 8OH minus, because the complete equation multiplied by 2. Now add it to equation number 2. It is I minus plus 6OH minus gives you IO3 minus plus 3H2O plus 6 electrons. Cancel out the common terms which are present on reactant side and product side. So first cancel out 6 electrons with 6 electrons. 3H2O by 3H2O. 4H2O minus 3H2O gives you 1H2O on reactant side. 8OH minus, and here we are having 6OH minus. Cancel out 6OH minus, or we can say 8OH minus minus 6OH minus gives you 2OH minus on product side. So overall equation will be M2MnO4 minus plus I minus plus H2O gives you 2MnO2 plus IO3 minus plus 2OH minus. In this manner, it is balanced in weakly basic medium by ion electron method. That's all in the balancing part through ion electron method. Thank you and have a good day.